domain and range of logarithmic functions. So we know the argument we have in logarithm should not be negative or should not be 0. So that means this needs to be strictly greater than 0 or positive. So then we say in the domain 2x minus 10 should be greater than 0. So then you can see 2x is greater than 10 and then x is greater than 5. So our domain will be 5 to infinity because we say greater than 5. So you have a 5 here, goes all the way to infinity. Now what about range? If you have a logarithmic functions, your range will be all real numbers, negative infinity to positive infinity. And the reason is, you can see the graph of this function, we say greater than 5, 1, 2, 3, 4, 5. So then the function will go actually like this. Is the logarithmic function. Graph look like this. So at x equals 5, we have a vertical asymptote for this function. I'm taking second example where I have argument like this. So I need to say the same way for domain. This will be greater than 0. Now you can solve this problem two ways. One is just add 2x both sides, get like this. So this one is same as 2x less than 9. That means x is less than 9 over 2. So then when you put here 9 over 2 somewhere here and goes all the way to the left side. So then domain will be negative infinity to 9 over 2 and the range will be negative infinity to positive infinity. We have a vertical asymptote for this function at 9 over 2. Now let us look at intercepts. So we say x-intercept. X-intercept, we know that y will be 0. So you write logarithm base 7, 9 minus 2x equals 0. Now we know the property of conversion. So then you say 9 minus 2x is 7 to the 0, which is 1. Now we need to solve for x. In this case, if you subtract 9 both sides, you get negative 2x equals negative 8, and then x will be equals 4. So your x-intercept is 4, 0 is the x-intercept. Now what is y-intercept? For y-intercept, we know that x is 0 and then we get y equals logarithm base 7. If x is 0 then it is just 9. So then this is my y-intercept. You can write like this or you can use your calculator and write a simplified answer like this. So our base is 7. Okay, thank you. Take another example where I have quadratic argument. So for the domain, we know x square minus 4 greater than 0. So to do this inequality, first you solve x square minus 4 equals 0 and then x will be plus or minus 2, the way we have solved inequality in chapter 1. So this one, now put here negative 2, positive 2, and then check the sign of x squared minus 4 at the test points, negative 3, 0, and then 3. So if I plug negative 3 here, you get 9 minus 4, that gives me positive. When I plug here 0, I get a negative. When I plug 3, I get a positive. So that means my domain will be this side and that side. So this side will be negative infinity to negative 2, and then other side will be 2 to infinity. So this is your domain, and the range again will be all real numbers, negative infinity to positive infinity. So I show you the graph in calculator. I'm typing logarithm x square minus 4. The base here, you have a. You can put any base. The basic shape will be fine for the domain and range. So I'm just taking common logarithm. So when you graph it in the standard window, so look like it goes all the way down. All the way down. You have vertical asymptote at 2 and at -2 here. So that's why the range is -infinity to +infinity. But domain is here, -infinity to -2 here, and then 2 to infinity on this side.